Welcome to this presentation covering data warehouses on AWS. My name is Dilip Kekla, and I'm the Redshift Business Development Manager at AWS.
And this is Matt Scare. I'm a Principal Specialist Solution Architect for Data Warehousing at AWS.
In this session, we'll talk about modernizing your data warehouse. So you may ask me, why should I modernize my data warehouse? As you're seeing around you, there is a huge amount of change happening in the world of data. The first is the exponential growth of event data. We hear from our customers that a lot of data growth is coming from event data, meaning machine-generated data from things like IoT devices, log files, clickstream data, social media. Even structured data is growing faster. And the traditional data warehouses, they are not designed or optimized for storing all of this unstructured data. They are designed for structured data. And with on-premises data warehouses, with structured data, the customer has to plan for data growth ahead of time. Hence, they have to over-provision hardware. The unstructured data and capacity planning, they are real challenges. Another change is customers' need for an end-to-end insight from all their data. Customers want a complete view of their business, and they can achieve that with a single view of all the data. Now, traditional on-premises data warehouses hold a subset of the data. Also, they are not designed to run analytic queries, and the rest of the data is in other data silos. Building an on-premises enterprise warehouse with all the data is extremely costly, and it's not scalable at exabyte data volumes. To add to all this, customers want a real-time view of the business and not wait for the ETL load to complete at the end of the day. So these are the challenges that need to be addressed. Matt, from your engagements, what do you see as the typical pain points for on-premises warehouse customers?
Yeah, I think a few of the areas that we bump into are people are interested in trying to integrate their silos of data into a single view of their customer. And then also, they're trying to control rising infrastructure costs. The third trend we see are migrations to the cloud. Having an analytics data warehouse on the cloud addresses challenges we've shared so far. Migrating off on-premises data warehouses has many benefits: performance, availability, cost, manageability, and flexibility, all without compromising on security. As products like Netezza reach the end of support, we know a lot of customers are interested in taking advantage of the migration tools and programs AWS and our partners offer to move to the cloud.
This is what we are going to spend time discussing today. With a modern data warehouse, you'll be well positioned to take advantage of the exponential growth of data and the benefits of getting end-to-end insight from analyzing all your data. Now, we spoke about a cloud data warehouse. We'll share the benefits you'll realize as you migrate to it. We touched upon getting insights from all your data, and that is to answer much more sophisticated end-to-end business questions and gaining a competitive advantage. For example, combining revenue data with clickstream data can answer questions about customer behavior prior to purchase. Scale and elasticity and flexibility, as you're aware of with on-premises infrastructure, is not possible. You'll have to over-provision resources to handle your business peak level of activity. Now, with cloud computing, you can provision the amount of resources that you actually need, knowing you can instantly scale up or down with the needs of your business. This reduces your cost and improves your ability to meet your users' demands. You also have the agility to test new solutions quickly and easily. The cloud allows you to innovate faster. You can focus your valuable IT resources on strategic and value-added activities. For example, instead of managing backups and patches, your team can spend time building deeper analytic solutions, predict the market direction, or what key actions the company should take to stay ahead, thereby differentiate your business and transform customer experiences. The cloud also allows you to trade capital expense for variable expense. You only pay for IT as you consume it. Plus, The variable expense is much lower than what you can do for yourself because of the larger economies of scale at AWS. Now that you have learned about the benefit, let's take a look at the architecture customers are moving to realize the value of full data. This is the data lake architecture. Amazon Redshift, a cloud data warehouse, lives inside your greater data architecture that includes a data lake. This means your Events data in the data lake and your business data optimized in the data warehouse. You still get the benefits of a cloud data warehouse like speed, easy to set up and use, and the ability to run complex analytics queries against petabytes of structured data. Including the Events data, Amazon Redshift enables customers to directly query and join their data across both their Redshift data warehouse and Amazon S3 data lake, giving customers a lake house approach to data warehousing. Amazon Redshift is the only data warehouse that extends your queries to your Amazon S3 data lake without moving or transforming data. This is possible with the Redshift Spectrum feature of Redshift. So the open data formats like Avro, CSV, JSON, ORC, or Parquet that you would store your data in your S3 data lake, all of that can be queried with Spectrum, which is a feature of Redshift. This gives you the flexibility to store highly structured, frequently accessed data in Redshift, as well as keep exabytes of structured and unstructured data in S3. And the best part? Query seamlessly across both datasets and get unique insights that you would not be able to obtain by querying datasets independently. Matt, can you talk a little bit more about that?
Yeah, sure. We spoke about accessing data in S3 from Redshift, but how about going the other direction? In this lakehouse world where the data is stored both in Amazon Redshift and Amazon S3, customers also have an easy way to get the results back from Amazon Redshift queries into Amazon S3. With the Redshift data lake export capability, you can also save the results of a query that you have done in Redshift into your data lake in an open format such as Parquet. This means you can analyze that data with other analytic services such as SageMaker, Athena, and EMR. During the unload command, Redshift automatically takes care of the data formatting, partitioning, and the data movement itself to S3. This ability to take data from the data lake to the data warehouse and then back to the data lake is what we call our data lake architecture.
We listen to our customers and build services based on the needs. A fairly new AWS service, AWS Lake Formation, is available to you to build out your data lake. It enables the creation of your data lake in days instead of weeks, and you benefit from security, access control, and more. Even if you have only structured data, a data lake allows you to consolidate all your data sources and build a future-proof architecture. Of course, with the benefits of being part of the AWS Analytics ecosystem, Amazon Redshift is natively integrated with other AWS services like AWS Glue to extract, transform, and load your data into Redshift. The Amazon Kinesis, the data firehose, is the easiest way to capture, transform, and load the streaming data into Redshift for near real-time analytics. You can also use Amazon QuickSight to create reports, visualization, and dashboards. And in the future, if you have a new AWS service or a partner service, they too would be able to work with this future-proof data lake. Amazon Redshift has the most customers and is proven for large data warehouse deployments. Customers such as Comcast, Asurion, Workday, Yelp, Nielsen, Fannie Mae, and Warner Brothers presented their stories with us at reInvent 2019. For use cases involving hundreds of terabytes of data or more, Redshift is the proven solution for analytics at scale. We benefit from the fact that Amazon Commercial uses Redshift for one of the largest analytics deployments on the planet. with over 500 petabytes of data in the Redshift clusters. They are one of our largest customers. Now let's talk about a few reasons why customers choose Redshift. We have already discussed the data lake-based architecture for your analytics. That's the data lake and the AWS integration. Use cases like data sharing, real-time analytics, AI, ML can be performed without re-architecturing because Redshift is fully integrated with your data lake. Redshift delivers three things that our customers consistently tell us matter the most when it comes to cost. One, the usage-based pricing instead of license-based pricing. And with that, the customers can get started easily. Start small with just 25 cents per hour. Scale to a terabyte for just under $1,000 per terabyte a year. Another benefit, great value as you scale your data warehouse because it's the only data warehouse that provides reserved instances, which save you up to 75% compared to your on-demand prices. This is when you commit to a 1 year or a 3 year reserved instance term. As the size of your data grows, with the managed storage available in our newest RS3 node, infrequently accessed data can be stored cost effectively as well. The best part on the cost side is predictability. Predictable month to month spend with no hidden charges and surprises. Unlike other cloud data warehouses where you need premium versions for additional enterprise capabilities, Redshift pricing includes built-in security, data compression, backup storage, and data transfer. Redshift also provides predictability in month-on-month cost even when you have unpredictable or highly concurrent workloads. Each Redshift cluster earns up to an hour of free concurrency scaling credits for every 24 hours of usage, which can be used to offset the cost of transient clusters that are automatically added to handle high concurrency. Matt, reaching out to you, do you want to cover the other?
Yeah, happy to. I think another one to bring up would be the scalability. Whether you're scaling users or data, Redshift is equipped to help you grow. Redshift clusters can scale from as small as 160 gigabytes to 8 petabytes of storage, resizing being completely managed by AWS. So there's no limit to how often or how much a cluster can scale. With concurrency scaling, you can automatically deploy compute resources when they're needed to handle thousands of concurrent users and queries. You can also scale to exabytes of data with your Amazon S3 data lake by querying it directly without needing to load it into your data warehouse. Another one that customers often bring up is ease of use. So Redshift is simple to set up and operate, and most administrative tasks are now automated, such as backup and replication. Redshift has automated backups and is fault tolerant. Redshift automatically adds clusters as concurrency increases and optimizes queries automatically. Redshift provides advanced workload management, query monitoring rules, and detailed monitoring metrics that allow you to meet your performance needs. New capabilities are released transparently, eliminating the need to schedule and apply upgrades and patches. You'll benefit from AWS support and a 99.9% SLA. And with Redshift Advisor, you'll receive prompts to make changes to continue to optimize your workload. And another one that's great to bring up is just simply the best performance. So Redshift is the world's fastest data warehouse with up to 3x better performance than other cloud data warehouses, and it keeps getting faster. Continuous performance improvements and optimizations have made Redshift 10x faster than it was just 2 years ago. This is possible because of the lessons we've learned from processing over 2 exabytes of customer data every day. New innovations like Aqua, the advanced query accelerator, which will soon be in preview, will introduce even greater performance improvements for this new scale of data.
Let's look at a few customer examples now. Fannie Mae were looking to reduce their total cost of ownership, but needed a secure, compliant, and a scalable warehouse that was also performant at a very large scale. With Redshift, they achieved all of that and now also spend less time administering their warehouse. Their team, instead of focusing on doing backups and administrative tasks, is focused on getting value from the data for the business. Now, with that data lake, they utilize Redshift Spectrum. Now, Matt, you have been working with Fannie Mae. Anything you want to highlight about this customer?
Yeah, with Fannie Mae, we've seen a lot of adoption of on the Redshift Spectrum side, as well as just the simplified administration is really something that they're enjoying and being able to focus on what differentiates them rather than just sort of the day-to-day maintenance tasks.
Thanks, Matt. We have tens of thousands of customers who are using Redshift. It is most broadly used data warehouse in the cloud. These are companies like Electronic Arts, Aetna, McDonald's, Yelp, Dow Jones, and Pfizer, Intuit, Liberty Mutual, just to name a few. And we have more and more customers gravitating to Redshift in significant part because we are continuing to iterate at a very fast clip. The Redshift team has delivered more than 200 new capabilities just in the last 18 months. Far too many to cover, so I'll just highlight a couple that I think have really mattered most to our customers. The top of the list for them is ease of use. In Redshift, we have automated maintenance tasks that carry out in the background, and the user does not have to worry about tuning the warehouse, even as their data pattern changes or their workload pattern changes. Redshift dynamically adapts to those changes. Performance is on top of everyone's mind. With concurrency scaling that we had launched about a year ago, Redshift automatically adds and removes capacity based on unpredictable demand. It's incredible how many of our Redshift customers are already using concurrency scaling. And because we give an hour of free concurrency scaling for every 24 hours of usage, over 95% of our customers are using it for free. Just before reInvent, we released materialized views that's still in preview, which takes your most frequent queries and pre-computes them and caches the aggregations and filters and even joins between tables, which makes your queries go much faster. We already spoke about the lakehouse architecture, which is made possible with the feature of Redshift Spectrum. And not surprisingly, as people start querying across both Redshift and S3, they also want to be able to query across their operational databases, where a lot of important data sets live. So at reInvent 2019, we released Federated Query, which now lets you query across Redshift, Warehouse, your S3 data lake, and our relational databases, including Aurora, Postgres, and RDS SQL databases. So when you step back and look at Redshift, it's the most broadly used data warehouse in the cloud. It's up to 3x times faster than anything else out there. And if you don't fudge the benchmarks, it's up to 75% less expensive than anything else out there. And yet, what we are looking around the corner to continue to deliver new innovations like Aqua, the advanced query accelerator for Amazon Redshift, to continue to help you do analytics at a scale across data as it grows. Let's look at a few more customers who have benefited from Redshift. We all know Nielsen, the information, data, and measurement firm. They produce data and analysis that enable decisions. The Nielsen TV measurement products measure everyone, everywhere. Their technology and platforms need to evolve to scale up to the additional content coming in and support the ever-changing methodologies to report on that biz data. We are running a legacy on-premise data warehouse based on Netezza with a monolithic architecture that had limited scale. Nielsen redesigned their architecture with Redshift. The new purpose-built solution provides seamless end-to-end orchestration for their entire platform. With the scalability and elasticity available, they can handle the ever-changing analytics needs of the team and increase efficiency. Now, this architecture also provides flexibility to continue to optimize cost with offers like spot instances. Now, Matt will cover a little bit on the architecture of Nielsen.
Yeah, happy to. So Nielsen's vision was to align the new solution to the overall vision of their platform. Their current Netezza-based solution was redesigned into a mix of data warehousing, and transient services as part of the data processing pipeline. The focus of data shifts to the data lake, separating storage and compute as independent layers, and the data itself becomes a product. The other point is that they're able to leverage Redshift, where they have a long changing dimensions and one off batch changes where they can leverage EMR and Spark.
Let's look at one more customer, Asurion, a provider of device protection and support services. They serve over 280 million smartphones and other consumer electronic devices. They had a wide variety of relational from OLTP databases, non-relational data, from telephony, voice, text, claims data, social, from over 290 million customers. And they wanted to do analysis on all of this data. So it's like structured data, transaction data, warehouse data, unstructured data all together. They use S3 as the data lake to store all the data in a single location. They use EMR to process raw data. And for fast BI, they use Redshift. With this architecture, they can now carry out analysis across all their data sets. And for each of their user types, which could be BI users, reporting users, and data scientists. At this point, we have seen the benefits customers have achieved migrating off on-premises warehouses to the new data lake architecture. Now let us talk about your migration journey to Redshift. Some of the best practices customers are following to have successful migration. And for this, I turn it over to Matt.
Thanks, Dilip. So each customer has a unique migration journey and wanted to highlight three of the phases here. Typically, we see an analyze and plan phase, a workshop and pilot phase, and then a migration phase. Underneath those, we wanted to highlight that AWS can support the customer to whatever extent you want throughout that entire journey. So that's first and foremost. From somebody who works in the field, a few other things to highlight there is that for that analyze and plan phase, another great complement to that is to think about what would you like to do, and now that the data is in the cloud, what would be this sort of a new possibilities that you had never been able to do before. So those are great things to capture there and share with the AWS account team, and so we can see what we can accomplish with that. The other thing I wanted to highlight was the proof of value. So many people are comfortable talking about proof of concepts, but proof of value may be a new term. And with that, it can be some of the more mundane or less data-centric elements of your, otherwise your larger proof of concept that we can just handle and demonstrate. So such as connectivity using JDBC or ODBC, or connectivity to QuickSight, things like that. That's a great way to accelerate the project and to share those with the AWS account team, and we can help work through those in a whiteboarding session or through a series of demos. Let's look at each stage in a little more detail. The first one is to analyze and plan. This is a great opportunity to figure out the responsibilities of your AWS Analytics account team. We want to partner with you on your journey and save you some time and money. Typical steps in this stage include discovery and planning, building a migration business case, and gaining or supplementing the team with migration expertise, and then finally writing the migration plan. The second broad category there is to workshop and pilot. And this is that proof of value that I discussed earlier, as well as the proof of concept itself. These are typically, what I find, are typically developed in partnership with AWS experts and partners and can help you get ready for the migration. Tools like the schema conversion tool and the database migration service will help expedite the process, and we'll do a little walkthrough for that in a few minutes here. Typical steps in this process include creating the new targets, modifying and developing BI and apps to have a dual target, and to modify the ETL to also have a dual target, and finally refining the skills and looking for and correcting any errors. And the third category is the workload migration. Once you begin the migration, you can expect to integrate, test, monitor, optimize until you fully realize the cloud benefits. This is an exciting time for the organization because you begin to realize the benefits of the modern data warehouse, like we talked about earlier. So with all these factors in mind, we developed the database migration service and the schema conversion tool. We designed them to be simple, so you can get started in less than 10 minutes. They're designed to enable near zero downtime migration, and we designed them to be kind of a replication Swiss Army knife to replicate data between on-premises, RDS, EC2, and across database engine type. All are supported. So if we look a little bit deeper for both SCT and DMS, you can see they cover a number of AWS services to make the whole process very easy. Let's dig into the AWS schema conversion tool in a little bit more detail. These extractors are installed on your equipment and can communicate with the source database, such as Vertica, Oracle, or Netezza, for example. And then as you configure these, they'll move the data to your target, such as Redshift, in an optimized fashion. So a natural question would be when to use the database migration service and when to use the schema conversion tool with the extractors. So there's a few decisions that might inform the choice of one or the other. Although in the data warehousing environment like we're talking about today, you'll tend to use the SCT extractors. One thing to highlight though is if you have a CDC where you're doing change data capture, such as with Oracle, then you will want to use the database migration service. Another way to look at this is to look at the supported sources between DMS and SCT. And there is a bit of overlap here. But for legacy data warehouse applications such as Netezza and Vertica, the SCT extractors tend to be what we use. And finally, a few guidelines for this. As I mentioned earlier, if you're looking for change data capture, then the database migration service is the right tool for that. And if your data set is larger than 10 terabytes, then you're probably much more likely to be using the schema conversion tool extractors. We also wanted to highlight that if you do have a network issue where your network may be slow or perhaps even unreliable, the SCT extractors do work with AWS Snowball as well. So then you can have that be sent via truck to AWS. So now let's just do a sample walkthrough of going from Netezza to Redshift. So the first thing we're going to do is have the schema conversion tool extractor talk to Netezza. And so here we're just running from Netezza, this is our test table. So we're going to get the count here. So this is going to have about 33 million rows. So we know that's what we want to end up with on Redshift. So now we'll do the setup. This is going to be the configuration itself from within the schema conversion tool. So we give this project a name, can be whatever you want. And then this is going to be OLAP, of course. So we're going to go from Netezza to Redshift. So you just pick the source and the target. And now we can test the connection, and then we can move on to doing the same thing on the Redshift side. So we're going to test the connection now to Redshift, make sure that that's all set up properly. So here we're browsing the Netezza instance itself. So we have a test database, and we're just going to navigate down and find the table, in this case for our sample we want to do, but you could select the entire database or a particular schema or subset of tables, whatever you want. We're just going to do a single table in this case. So we're going to pick test 4. It's as simple as convert schema. So since we've done this before, we're going to replace the existing target in Redshift. We just say it's okay. We're going to continue. We're going to collect some metadata about the Netezza data. This could help us when we're determining things like a sort key or a distribution key. And then now we've built that DDL, and so you can optionally then apply it to the Redshift cluster. And so this is actually doing the create table right now. So now we're going to do the data movement itself. So we've created our DDL, we've migrated our DDL from Netezza to Redshift, and now we're going to move the data over for this table. So the first thing we need to do is to register that software agent, the extractor agent that we installed. We didn't show that as part of this video. That's just a simple installation. We specify the host and the port, And you do have the option to use SSL if you want to. So now that we've registered our host, we have an optional step, which is where we're going to build virtual partitions. This is to tell the schema conversion tool to work in a massively parallel fashion. And so in this case, we're going to create a virtual partition, and we do that by specifying the column that we want to partition the extract to run on. So in this case, we have a column called PK. That's the name of the column. We're going to use range partition for this. And in this case, I'm being a little bit lazy, and we're just using a comma-separated file. And so this is going to have, in this case, I think 32 different values, and this is going to automatically build the partitioning for us. And this will allow us to do subtasks within that big task. So here you can see the result of that is this range that will allow us to work in a massively parallel fashion. So now that we've set up our virtual partitions, we can move the data itself. So we're going to create a task for this. We can call it whatever we want. So let's use test4 with virtual partitioning. And we're going to extract the data, upload it to S3, and then copy it into Redshift. So we've set this up so you can see there's 3 tasks on the top. You notice as we hit start there was a plus sign that converted to a play button. And that is information to tell you that there are subtasks associated with that. So if we click on that, we can see the subtasks. And here you can see we have 32 extractors running simultaneously. Some are running at one time or another. And so this is just going to go through the process of pulling the data, but this is a pipeline process. So as soon as some of these subtasks finish, the upload task can start. So it's truly a pipeline process. We're not waiting for one before starting the next one. We can do this all simultaneously. So some data has already landed on S3, and that data is already being copied to Redshift. So we can just let this go. We'll handle it automatically. And if you had specified, this is one table, but if you had done 1,000 tables, it would work exactly the same way. Now we're done. So I'll show you the result. So we've extracted all the data from Netezza. We've copied it to S3. We've loaded it into Redshift. So now we're using SQL client here connected to Redshift. We can make sure that we have that same 33 million rows or so. So we'll run that, and there's all of our rows. So if we kind of recap on what we did there, we did the whole process. We just did it for a single table rather than 1,000 tables or 10,000 tables. First off, we migrated the DDL from Netezza to Redshift using the schema conversion tool, and then we used extractors to extract the data from Netezza to Redshift, rather. And then we migrated the data itself. And then now I'll hand it back to Dilip.
Our partners play an important role in customer migration. They can do the heavy lifting as well as train our customers in the process. They can help ensure that you are successful by following the best practices and leveraging the right tools. At AWS, we have a different set of partners. To help you migrate your data warehouse to Amazon Redshift, the AWS competency partners can assist you. You can check out the URL for a complete set of partners. We also have technology partners who have built online products that integrate with Amazon Redshift. These partners enable you to gather data insights and analytics productively at scale. Another set of partners customers can leverage are consulting partners. These partners have analytics competency, share with you how you can leverage all AWS services, and reduce your time to build out a complete end-to-end architecture that would include a data lake and also migrate to Amazon Redshift. Now, to learn more on how other customers have leveraged Redshift, you can review the YouTube videos or reInvent sessions. You can also engage partners who we spoke about just now or AWS professional services to augment your team and get ramped up quickly. If you want to get your feet wet yourself, that's not a problem. You can get started with a free trial of Redshift on the Getting Started page. So that's aws.amazon.com, Redshift, getting-started. And anytime if you have any questions, is the email ID that you can use. That concludes our presentation, and now is the time for question and answer. Thank you.